All right, this is a recording of the September 4th Friday lecture for anyone who needs to repeat anything or miss the Zoom meeting. So what we're talking about is getting ready for a lab that you'll need to have done by Tuesday. First of all, you want to make sure that you've read the welcome letter and you've seen the supply list. Today we'll need a ruler and a ball to complete the lab. Really any ball that bounces and any type of measuring stick will work, whether it's a ruler or a tape measure. Any of those will work. Okay, so what we're going to be looking at is the lab, the ball drop lab. Okay, so what we need to do is start at the beginning. All right, so what we're trying to do is plan and conduct a scientific investigation, choosing a method appropriate to the question being asked, and then we're going to collect, analyze, and display data using calculators, computers, or Chromebook, and other technical devices such as your phone would all be helpful. Okay. All right. So what you're going to need is the ball, your measuring stick, some sort of tape or Post-its are very helpful. Also your phone or Chromebook. All right, so what we're trying to do is predict the necessary drop height that will cause the ball to be bound back to an exact set level. So the first thing, and one of the most important things you're going to do is do some poking around on the internet and find out a suitable hypothesis. Okay, so for my demonstration, I'm going to use a racquetball. So I would search what is the percent return on a racquetball, and that should tell me if I drop the ball from 0.8 meters, then it will bounce to a height of 0.5 meters because racquetballs have a percent return of 0.8. This is an old racquetball, so I assume it's going to be slightly less. Okay, so absolutely important you have a numbered, measurable, provable hypothesis. Okay, that has to happen before you collect your data. All right, then we're going to go into data collection here. So let's look at one of the old instruction sets here. Okay, so in 2008, there's this great write-up for how to do this. Involved multiple people and making sure everything is at the correct height, which is the correct height for observation is still going to be important. But human eyes are really bad in terms of quality and accuracy, especially with moving objects. So if you can use your Chromebook camera or your phone and take a real quick video at the correct height, then you're going to get much better data. If you have an iPhone or something that runs iOS, you can use Skyview Physics, which is an excellent program. I only have an Android product, so I just use a camera. Sometimes I'll use slow-mo if it's harder to see. Okay, I also, by the way, I was lucky enough to have a ball that contrasted nicely with the background, so the video will pick it up really nicely. Right, so from there, if I step back and look at what I've set up on the wall here, okay, what we see is I've labeled each one of these and marked it 20 centimeters apart. So if I go 20, 40, 60, 80, 1 meter, I can drop from height of 1 meter. And then I'll measure from the same point in the ball every time. So if I measure from the bottom of the ball at the top, I need to measure from the bottom of the ball when it rises based on the video that I get. Okay, so if I'm going to do that, I'll drop it from my set height. Remember, I can do multiple drops from one height and multiple drops from the next height. So I drop it. Okay, hopefully my video picks up where the return is. Okay, I drop it again. I see if the video returns the same results. Okay, and then I can start building my data. Okay, so with that, I now have something I can put into a table. Okay, so I like to do all my writing in Google Docs and all my number crunching in Google Sheets. If you have other software, that's Google Docs and Google Sheets are kind of the bare minimum. There's definitely better software out there if you have those available to you. When I put this into Google Sheets, I can take my numbers, okay, and I can say insert chart, okay, and that will insert the chart there, okay, and then you can start playing with different things, changing the series, okay. I can add my trend line, and I can add data labels. I don't want data labels. I can add error bars at 10%. Okay, I can change the colors and the thicknesses and all those things. Okay, so I've done one where I added all the points here, all the values. Notice here we have a nice equation for the slope. That means that with measuring just a few points, okay, do more than 2, make sure you have, I always thought 7 was kind of a magic number in terms of statistics. If you have multiple points here, then anywhere along the line, you should be able to have a good, solid prediction, right? The goal of science is to establish theory and predict future events, okay? So if we have a theory that the ball is going to bounce according to this equation, then we can predict not just in between the points, but we can extrapolate out. What about 2 meters? What about 5 meters? What would happen there? Okay, so we want to make sure we have built a scientific theory that predicts the physical results. Okay, so that was all done in Google Sheets. Okay, and then you can start dropping things into the assignment in Google Docs. Okay, so again, here's where you're going to put in your numbered measurements or your numbered predictions. You're then going to list your materials. Try to be as specific as possible. Feel free to include pictures in both the materials and diagram portion. Diagram needs to be labeled and try to include any measurements you can in that portion as well. Okay. You could do things like the diameter of the ball or the weight of the ball, or those types of things could be useful. Okay. Then your procedure. The procedure should be so detailed that other people can reproduce the results. If they got a racquetball and they bounced it on a similar floor, they should get similar results as I did, okay? And then you take your data. Nice thing about Google Sheets and Google Docs is you can just cut and paste it and drop it right in there, okay? All of this page 1 can be done in groups. Okay, so if you have a neighbor or someone you're going to be spending time with, and that's also in AP Physics, then you can work together for this first part. Okay, that's the end of the group section though. Once you have your data, you need to part ways and do your own analysis and conclusions. Okay, so if we have a few points, you had your theoretical based on your hypothesis, okay? So if I said it was going to do a 60% return and it actually returned 70% return, then I can put those numbers in there and I can get my accuracy and percent error of these things, okay? This also says graph versus final measurements because we're going to have a part 2 that's going to come next week. That's going to use more information as well. Okay, your major sources of error. Human error is not a specific enough answer. Is it that your thumb didn't move fast enough? Is it that your eye didn't move fast enough? Is it that you didn't put the post-it notes in the right place? What was your action that was the source of the error? Okay, try to list and be as specific as possible on this portion, and then those errors, How can you minimize them? Okay, are you going to have, I don't know, a robot let it go? Are you going to have a laser level set the post-it notes? Are you going to have a better resolution camera? What is it that you're going to change based on what you have available to you between now and Tuesday? Okay, and then this needs to be something that is very doable. Okay, be ready for me to say, do this last part. So if you say, these are my errors, these are the questions I have after my results, I would like to repeat my experiment doing these things, okay? Then that is what I'm going to look at as your grader, and I'll say next week, okay, now do it. So make sure these are things you are prepared to accomplish. Okay, it's also, by the way, how scientists continue to get funding. They run an experiment, they look at it, either they spot an error that needs to be fixed, or a new question arises out of the data, and they want to get more specific and try to answer a new question based on the old results. Okay, so those are all things that we're going to look at based on what is your next logical step. Okay, so which is why you could eventually come back and say, oh, I have a data, now I want to see if I did drop it from 5 meters, will that line continue? Okay, that would be a type of thing you need to do, but it has to be something you can absolutely do. My ceiling is not 5 meters tall, so there's no way I could bounce it on the same flooring and get a new result for a 5 meter experiment. Okay, so with that, we have our data, we have our graph. Okay, you write up your conclusion, including your proposal. Okay, and you're going to be prepared to do it. One of the things I like about physics is how reproducible it is and how vital that is to science. If we looked at the 100 studies published in journals in 2008, 75% of the experiments and half the cognitive studies failed the replication test. Okay, that is not a good news for social psychology. Okay, if they're going around saying things that no one else can reproduce, then it's hard to build a theory on that. Okay, if you say things like every time you should never go grocery shopping when you're hungry, based on this 1970 study, well, if no one's ever tested that study to see if it's still true, then you're modifying your behavior for nothing. Okay, and again, looking at these social psychology experiments, even when scientists could replicate original findings, the size of the effects was found to be on average half as big as first reported. Okay, so we don't want any of that in physics. We want to make sure every time we drop the ball, the theory of gravity holds. And every time the ball bounces, your theory of bounce return also holds. And it's true every time for any height. Okay, so that's what we're looking for. All right. So hopefully between now and Tuesday, you have planned and conducted a scientific investigation, choosing a method appropriate to the question being asked. You've collected and analyzed and displayed data using your calculator, computer, phone, or any other devices. Okay, final note about grading. Notice this is your first master task that falls within the 80% grade mark. So it is vital that you do it and you have your first round of results for Tuesday so we can begin our discussions. Okay, that know, want, learn was your first practice task. It falls within that 10% category. So not as vital, but it's still things I want to make sure I know about you and we get used to doing all the practice. So our master tasks get the highest possible score. Okay, and with that, I'm going to sign out and I'll see you all next week.